Hi everybody. Here we're going to go over the instructions for the first lab. This is the first actual lab. This is going to be the electric field lab. And first thing to do is you're going to enter your student ID in cell A2. And next, if you zoom out, let's go ahead and look at the structure for the lab. So there's a couple different sections. Part 1 has, it ranges over sections 4 through 9. And you can see them here. So this is section 6, section 7, section 8. If you go out to the side, you'll see the different parts that are labeled. So section 9 right there. So that's part 1, and you can see if you scroll down, you'll notice part 2 over here. Part 2 includes sections 10 and 11 and 12, and you can see here for part 2 sections 10, 11, and 12. So the instructions are listed in terms of the sections that you'll enter the data. So first thing you'll do is once you'll read the purpose, and then you'll click on this link here, and when you do, this website is going to appear. And what you want to do here is, this is what this part section 4 goes over, is to how to set up before you do the experiment. So I'll just go over it myself here. So first of all, uncheck electric field, check grid line, and check values, and check grid lines. And if you look here, if you notice this box, this length here corresponds to 1 meter. So you're going to use that as your reference. So you're going to take a positive charge, you're going to place it at this location here. This is going to correspond to 1 meter from the right side of the screen. And you're just going to stack these up until you get 12. Until you get 11 of these spheres stacked up. And once you've stacked them up, it should look something like this. You should have 11 of these red positive charges just touching one another and stacked in a vertical line. And the length of this vertical line should correspond to 2 meters. And then from here, you're going to take some blue negative charges and space them so that they're 4 meters apart from, or they start off 4 meters apart from this red line here. So that should be over here. And you're just going to stack these until you get same thing. But in this case here, 11 blue charges stacked on top of each other. And so this is going to be the setup for the experiment. You have, this is actually represents what's called, or we're going to represent this as 2 charged electric plates. You're just looking at them from the top. So this is going to be a plate that has a positive charge, and this is going to be a plate that has a negative charge. And so you're going to study the electric field between those 2 charges. But this is what this first part tells you here, is how to set up these charges. And so to take your measurements, you're going to make some assumptions. You're going to take this charge over here, this bottom positive charge on the bottom left, to be the origin of an XY coordinate system. So this is going to be the positive Y direction here, starting from 0 at the bottom left. And the line connecting the positive red charge to the bottom positive red charge to the bottom negative blue charge, that's going to correspond to the x-axis. And you're going to use that to measure coordinates of points inside this, in between these 2 plates. So now you can begin doing the experiment. So for the experiment, you're going to take this voltage sensor here, and you're going to place it within the region between these 2 plates. So you can see as you move the crosshairs, I actually can't magnify this, but as you move the crosshairs, you'll notice that at this location, this reading tells you the voltage at the crosshairs here. So what you're going to do is to move the crosshair from one position, measure the reading, and then you're going to enter that into the Excel spreadsheet. So let's see what this looks like then on the Excel spreadsheet. So this is going to correspond to section 6. And here in section 6, so let's zoom out here. So if you go to section 6, and you can see the setup again for what the experiment should look like before you start taking data. So in section 6, let's actually compare these two images here. So this charge here, this is at 0, 0. This point over here should correspond to x equals 0.5, y equals 0. This point over here should correspond to x equals 1, y equals 0. This point over here should correspond to x equals 0.5 and y equals 0.5. And so those are going to be your the locations of the coordinates inside this region. And if you look at this grid here, this first point over here, x equals 0.5, y equals 0, that corresponds to that location there. So what you're going to do is you're going to take your voltage sensor, place it at that coordinate, and measure the voltage at that location. So let me just go ahead and do that over here. So the first point that you'll fill in is this one over here, x equals 0.5. That's highlighted in purple. And then y equals 0. And this highlighted in green there. So their intersection is going to be over here. So at that coordinate, you'll go to the simulation, place your voltage sensor here. So at that location, whatever reading you get, you're going to place that. This reading you're going to record it into the Excel spreadsheet. So that'll be the first number. And also include the units for voltage here. So whatever the units for voltage, you'll select them from the list. And so let me just pick another point. Let's say that you pick this point over here. This corresponds to x equals 2 and y equals, so 1 second, and y equals 1.5. So then that means you have to go back into the grid, find x equals 2 here, and then y equals 1.5. So that's going to be over here. So you'll place the voltage sensor at that location. Whatever value you get here, you're going to enter it into the Excel spreadsheet. So whatever number you got there. And again, don't forget the units for voltage down here. And you're gonna fill in this grid, and that's going to be the bulk of the experiment. You're just going to take your data within its region, voltage at different locations. You're going to enter them at the corresponding location in this grid. And that's going to be it for the data taking part of today's experiment. So next, what you'll do is so once you have the data filled in here, so let me just enter some numbers. So let's say that, well, let's talk about the first section here, then for section 7. So for section 7, you're going to create a graph, and you're going to you're going to graph voltage versus distance, or voltage versus x. So voltage should change and x should change. So that means that you're going to copy the rows you're going to copy specific rows. So the first row that you see here, so in section 7, is you're going to copy the data of voltage versus x for the row y equals 0. So the row y equals 0 is this one. So let's say that these are the numbers that you have here. So once you have this data from this computer simulation, you're going to take this row, and you're going to, so this represents, if you notice here, x is changing and the voltage is changing. So this is voltage versus x. And actually the distances for that first section are given to you here. So you'll just transfer the data, the corresponding data. So you can actually do it this way. You can type it in manually, or you can have Excel do it for you by just typing equals and then clicking on this cell, and then equals, clicking on that cell, and you can fill that in. So I won't do the whole thing, but you're going to fill in this table here. And again, don't forget the units for distance. You'll enter them over here. And then the units for voltage, you'll enter here. And next, you're going to repeat the same thing, but now at a new location. So again, you're going to measure voltage versus distance, but now at the height y equals 1. So that should correspond to this row over here. So whatever data you have in this section, again, I won't fill in the entire thing, but you're going to transfer these voltages onto that section here. So you can either type it in manually or you can have Excel do it for you. So at x equals 0.5, the voltage is equal to, let's see here. So at x equals 0.5, the voltage at y equals 1 corresponds to this value. But you can just have Excel do it for you. So just click equals, and then you're gonna, it should be this cell. And then you can keep on filling in the data. And so here, again, so at this point, this is at x equals 1.5, what is the voltage along the line of y equals 1? So this is the line of y equals 1. And at x equals 1.5, the voltage is this number. So you just, at that location, equals, and then click on that cell. And so you're going to just transfer, so you're not doing any experiments here, you're just transferring, you're interpreting data or transferring data so that you can interpret it. And that's what you're going to do. You're going to also do it for another line, voltage versus distance, but now for y equals 2. So that's going to correspond to the voltage readings that you get in this section here. And so you're going to just create 3 different tables of voltage versus distance along 3 regions in between this setup here where you have the charge plates. So once you've done that, then you're going to create 3 graphs. You're going to create the first graph of this one over here, voltage versus distance. That's going to give you 1 graph. And then you're going to create another graph, voltage versus distance. That's going to give you a second line. And then a third graph, voltage versus distance. That's going to give you a third line. So to distinguish the 3 lines, you'll also include a legend that tells you at what height each of these, or what values for y each of these correspond to. And it should look something like this. So if you notice here, I have distance, you'll enter the units in SI, the vertical axis, that's voltage, you'll enter the units for voltage. And if you notice here, I have 3 lines. So the the orange line corresponds to, actually here the blue line is the one that corresponds to voltage versus distance at y equals 0. And you can see there's a slope there for that distance, or for that at that location. And the orange line, that's voltage versus distance at the point y equals 1. And then the gray line, that one's kind of hard to see, but there's a gray line here. That's going to be voltage versus distance at y equals 2. So what you're doing here is just these 3 tables. You're graphing them all on the same graph so you can compare what the values are. So once you've calculated once you've gotten the graph and you've included access titles, title for the graph, trend lines, and a trend line equation, you're going to take the slopes here and you're going to put them, you're going to record them at this location here. So in this case here, this is voltage versus distance, and the slope, voltage over distance, actually represents the electric field in between these plates here. So the slope actually represents the electric field in between the plates. And you're just going to record those values. So let me zoom in here. So here, this is the electric field or the slope at y equals 0. So that should correspond to whatever number I have here. So at y equals 0, this is the slope that I get. And it says magnitude, so don't include the negative sign. And then you'll include the other slopes. So I'll just do the second one. The other slope is, for me, 2170. And don't include the signs. 2171. And what you'll do here is you're going to calculate the average of those 3 values. So let me just do the other one also then. The other one is 2205. And so now what you're going to do is you're going to get an average. You're going to calculate the average electric field across this entire region between the positive plate and the negative plate. So you're going to get an average of the electric field between those two regions. And so in Excel, you can do it manually, or you can have Excel do it for you. So you can just type equals and then average, and then just drag it across the numbers that you want to calculate. And then don't forget to enter the units for electric field. And next, you want to calculate the uncertainty in the electric field. So here, there's a formula for that. Let's go to where the formula sheet is. So you can see here, right there, so the electric field is a slope of voltage versus distance, and the error in the electric field is just going to be the standard deviation of the three values, but also divided by the square root of the number of trials, which in this case here is 3 trials. So you'll calculate the standard deviation. And so you can have Excel do this for you by just typing equals STDEV, dragging it across the numbers you want to calculate, but also divided by the square root of 3. And that'll give you the error for the electric field. Don't forget to round this though to 1 sig fig. And that'll complete the experiment for part 1. All you're doing in part 1 is you're getting a value, you're calculating the average electric field in between the positive and the negative plates. And so that's going to represent the average electric field within this region here. In part 2 of the experiment, you're still going to refer to the data that you got in this section here, but it's going to look a little different. You're going to select a different arrangement of those same the same data. So for part 2, what you're going to plot is now voltage versus Y at a constant value for X. So let's say that on your grid, you're basically getting the voltages along these vertical lines here. So let's say that at the first one, so let's see what the first value is. So it's voltage versus Y at a value of X equals 0.5. So here at X equals 0.5, you're going to copy the data in this column here. So let's say that you had some numbers for voltage. And down this column here. So you'll just take this information and copy it as is onto that section. So let me just go ahead and do that. So you can just take these data points and copy them and paste them as is into this section. And the next one is you're going to take the column of voltage versus Y, that corresponds to X equals 2. This should be X here. There's a typo there that I'll have to fix. But that's to correspond to X equals 2. So at X equals 2, let's see what that one's going to look like. That's correspond to data in this column here. So you'll take the data in the column X equals 2, you'll copy it, and then you'll paste it into this column here. And again, don't forget the units for distance, and then the units for electric field, actually for voltage here. Again, I'm just giving you general, these aren't the correct units. I'm just picking units from the list. And once now you're going to again have a table, well, 3 tables that correspond to voltage versus distance at 3 different locations. And just like the one from before, you're going to create one graph, just like this one over here. But in this case here, the one graph is going to be voltage versus Y instead of voltage versus X. But just like before, you're going to get the value for the slopes, and you're going to copy them into, so once you get your slopes here, you're going to copy those values into these corresponding regions here. So voltage versus, so change in voltage at X equals 0.5, that's going to correspond to the slope for this table here, and so on for the other ones. So you'll just fill in the slopes that you get for each of those three graphs. So you should have all the graphs on the same, all the lines on the same graph. And just like before, you're going to calculate the average of these of those values. You're going to place that over here, and then the error is just going to be the standard deviation divided by square root of 3, and that's going to give you the error in the change in voltage along the vertical direction. And that will conclude the experiment for the electric field lab. So the basic idea is that you're measuring, for part one, you're measuring voltage versus horizontal distance, and you're going to use that to calculate the average electric field. And then for part two, you're measuring voltage versus vertical distance, and you're calculating the change in voltage along the vertical direction. Now let's go ahead and take a look at the homework assignment. So the homework assignment are just questions that you have to read, and you're going to get to answer these questions, you have to read the theoretical section in the manual, which I'll give you a copy of in a separate file, and you'll just have to pick your choices from the drop-down list to answer these questions here. And so this is going to conclude the electric field lab.